On behalf of architect Ernesto and myself, Miguel Camacaro, we thank the Technical Committee for the approval of the research work in econometric model MLRM Analytic Hierarchy Process, AHP, to select the best alternative for a real estate investment case, apartment in Panama City, Panama, and to the organizing committee of this event for the opportunity to make the presentation to such an important audience. Human beings are living in a digitalized era where information is available to everyone. Data science has a very important role to play in the collection, transformation and analysis of the data produced, in a large volume, both structured and unstructured, which today is known as big data. In this context, a newlywed couple has conducted a study based on search engine techniques or web scraping applied to real estate websites to obtain reference market prices offered for multifamily residential units that allow them to start the process of acquiring an apartment in Panama City. From this research they have selected the following properties: PH Arenas Park, $165,000, PH Vista Marina Tower $170,000, PH Coral Tower $200,000 and PH Miradors Residences $168,500. The data for the selection of properties are shown in this table with the following columns: building where the property is located, area, number of bedrooms, number of bathrooms, parking spaces, age, if there is a balcony and if it has amenities such as swimming pool, playground, meeting room, game room, gym, sky bar, etc. In addition, information about the level or floor of the property and its corresponding total price. In the reflection phase, they ask themselves, are the prices offered in the real estate portals the real prices of the market? Now, if the answer is positive, what would be the best real estate investment alternative? To answer the first of the above questions, the young couple decided to hire an auditing company, Camacaro and Mock Valuation Audit, to carry out a real estate market study that would allow them to obtain information to verify whether the prices offered are market prices, in order to guarantee a good basis for negotiation. From the Multiple Linear Regression Model, MLRM. The auditing firm will use all the information contained in its publication, The E-Book of a Real Estate Appraisal, to estimate market values that can guide the couple in the real estate negotiation and investment process. The report to be submitted by the auditing firm must comply with national and international standards such as the International Valuation Standards, IVS, the Brazilian Valuation Standards, ABNT-NBR, and the International Property Measurement Standards, IPMS. In order to perform the advisory work, they will use the comparative method of market data for real estate appraisal. Conceptually, it is stated that the estimation of the value of a real estate property follows a research methodology based on the statistical analysis of a sample of sales and purchase transactions and offers in the real estate market. The results obtained by processing the data, empirical basis, are presented in a technical report identified as a real estate appraisal report. For the application of the market approach, the hedonic pricing method is used, which consists of estimating the value of a real estate asset based on its intrinsic characteristics, attributes, and extrinsic characteristics, externalities. This method is based on economic models where the value will be a function of the nature of the real estate and the conditions of the market where it is consumed or traded. An individual will pay more for a property to the extent that its attributes satisfy his needs. The greater the satisfaction, the more the individual will be willing to consume a product at a higher price. The market price modeling process requires the application of the linear regression model, which according to Gujarati is the study of the dependence of the explained variable on one or more variables, the explanatory variables, with the objective of estimating and/or predicting the population mean or average value of the explained variable in terms of known or fixed values, in repeated samples, of the explanatory variables. The equation of the simple regression model is as follows: Y equals beta 0 plus beta 1 times Xi plus epsilon I, with Y being the explained variable, Xi the independent variable, beta 0 and beta 1 the regressors, and epsilon I the errors. Price estimation with MLRM. It is very important to contextualize from a geographical point of view the location of the appraisable properties, starting with the country. The Republic of Panama is located in Central America, has an area of 75,517 square kilometers, of which more than 3,000 kilometers are coasts, both in the Atlantic and the Pacific Ocean. Panama City is a modern metropolis that has experienced an impressive growth during the last decades due to the accelerated demographic expansion characterized by the construction of large housing and commercial developments, where high-rise buildings dominate the panoramic view of the Panamanian city. The urban area under study has the Omar Recreational and Cultural Park, located specifically in the Corregimiento de San Francisco, near the Fernandez de Córdoba station with an approximate length of 5 kilometers, is an ideal place for sports and physical activities, such as exercise and recreational games. The physical boundaries are, to the northwest with Via Simon Bolivar or Transismica, to the northeast with Corregimiento Rio Abajo, to the southwest with Avenida Brazil and to the southeast with Autopista Corredor Sur. After analyzing the behavior of the real estate market and considering the characteristics of the appraisable property and its urban environment, an economic model was proposed where the total price of the property, as a dependent variable, is a function of independent variables such as construction area, number of rooms, bathrooms, parking spaces, age of the buildings, their quality, type of event, the level where the property is located and the distance to the valuation pole. The econometric model, whose dependent variable is pi, is represented by a multiple linear regression model. The population corresponds to multifamily residential units, with areas between 60.00 and 140.00 square meter, located in buildings with between 10 and 40 floors, located in the Corregimiento de Rio Abajo area of Panama City. The sample collected reached a size n equal to 97 data corresponding to market offers. This image shows the spatial distribution of the buildings where the properties that are part of the sample under study are located. This table presents the information on the identification of the variables of the econometric model. The first column shows the names of the variables, 1 dependent and 6 independent, the nomenclature of each one with its unit of measurement, then comes the description, its classification and finally the measurement scale. In this mosaic of images are the results of the calculation of the multiple linear regression model, starting with the estimation equation of the multiplicative type that facilitates the interpretation of the elasticity of the dependent variable to changes in the values of the independent variables under the ceteris paribus condition. The results are then presented in terms of the number of data and variables, the values of the correlation and determination coefficients, the F statistic and its significance, the residuals of the model, the standard deviation of the model and the number of outliers. The following image shows the variables with their scales, their elasticity, the T statistic, the significance and the coefficients of the regressors of the model. Highlighted in a red frame are the test statistics that will be used to substitute the scale values of the SADI table in the criteria comparison matrix as will be explained later. Here is the correlation matrix with influence to analyze the multicollinearity of the model variables. Next is the graphical part of the results to check the normality and homoscedasticity of the residuals, the presence of outliers, influential points and maximum-minimum points, as well as the model fit test. Next, the data of the assessable property and the point and interval estimates, with their confidence intervals, prediction intervals and arbitrage field. Finally, information on the degree of fundamentation and precision of the report, both in Grade 3 according to NBR 14653-2. Once the validity of the econometric model has been checked, the values of the properties offered are estimated, PH Arenas Park, the prediction interval, according to the ABNT NBR 14653-2 standard that can be used to estimate prices, for this case was 134,343.06 and 164,095.49 USD. The bid price of $165,000 is above the upper limit of the range. PH Vista Marina Tower, the prediction ranges, 162,594.43 and 200,236.69 USD. The bid price of $170,000 is contained in the range. PH Coral Tower, the prediction ranges, 167,484.99 and 205,724.59 USD. The bid price of $200,000 is contained in the range. PH Miradors Residences, the prediction ranges, 171,628.56 and 210,259.93 USD. The bid price of $168,500 is below the low end of the range. With respect to the result of the price estimation of the previous sequence, the following question can be asked: Is it possible to make the decision to invest just by analyzing the prices of the real estate? The answer is no. Now, what method can be used to help make the best possible real estate investment decision? Real estate investment and decision-making with AHP. In this table are the data of the variables corresponding to the properties selected for the application of the AHP. The first property is an apartment in Pérez Park, which has an area of 67 square meter, 1 parking space, 5 years old, the quality is 2. It is located on the 23rd floor of a building 1,157.96 meters from Parque Recreativo y Cultural Omar, with an offered price of $165,000. There is also the information of the other apartments located in the buildings PH Vista Marina Tower, PH Coral Tower and PH Miradores residences. In this sequence, the initial diagram is presented, with the objective corresponding to the selection of a property, while the criteria are construction area, parking space, age, quality, building floor and distance from the valorizing pole. As for the alternatives, we have the apartments located in PH Arenas Park, PH Vista Marina Tower, PH Coral Tower and PH Miradores residences. Ernesto, an expert appraiser who lives in Panama City, was consulted in order to prepare the criteria comparison matrix, and the following result was obtained. The appraiser considered the construction area variable to be much more important than the parking space variable, and the value 5 of the SADI table was entered, obtaining its reciprocal value. Regarding the age variable, the value 3 was entered and the reciprocal value was obtained. For quality, the variable construction area was considered slightly more important, and the value 3 and its reciprocal were entered. For floor, it considered between little more important and much more important, that is a value of 4, which was entered and its reciprocal was also obtained. For the distance to the valorizing pole, it considered that the building area variable is little more important, the value 3 was entered and the calculation of its reciprocal. Thus, the totality of the values of the elements of the criteria comparison matrix was completed. For the purposes of normalization, the columns of the criteria are added together. The table shows the values of the normalization of the variables. Once the normalization has been performed, the eigenvector, nx1, of the criteria is determined, corresponding to each element of the row the average of the values of each row. Then the total vector is determined by multiplying the matrix of criteria nxn by the eigenvector nx1. The vector lambda is determined by dividing the values of the total vector by the values of the eigenvector of the criteria. Thus lambda max is calculated as the average of the values of the rows of the vector lambda. Once lambda max, 6.57, is obtained, the consistency index IC is calculated as the quotient of 6.57 to 6 between 6 to 1, which is equal to 0.11. We proceed to calculate the RC consistency ratio, but first we determine the random index AI, using table of random index, RI, values for a discrete set of criteria n, in this case for n equals 6, AI is equal to 1.24. Then, 0.11 out of 1.24 is 0.09 less than 0.10, which is the maximum allowed for the size of the matrix extracted from table of the maximum consistency ratio, CR. All the criteria were represented by quantitative variables, so we proceeded with the normalization method of the values of the alternatives, for the cases of contribution, plus, and non-contribution, dash, that is, depending on the nature of each variable. This table shows the eigenvector matrix of the alternatives and also the eigenvector of criteria. To obtain the general weighting vector, it is enough to multiply the nxn matrix by the nx1 vector. By ordering the results, the ranking is obtained, with the property located in PH Coral Tower occupying the first place in the selection. Again we ask, is it possible to substitute expert opinion in the pairwise comparison matrix of criteria and alternatives? And can the statistical results of an MRLM substitute the values of the SADI table? From the multiple linear regression model, MLRM, and the T** criterion, the proposed replacement of expert opinion and the SADI table in AHP. For the proposed substitution of the values of SADI's fundamental scale, tests were made with the variations of the adjusted coefficient of determination when including and extracting the variables from the model, with the elasticities of the mean value of the explained variable, with the correlations between the independent variables, as well as the base factors associated with the variables in the estimation equation, But the results with the t** coefficients are more robust because they are generated directly from the model and expressly measure the influence of the associated variable with respect to the dependence variable, so that the higher the t**, the greater the importance of the variable in the model. The test statistics are presented in this table. To complete the table, each t* of each variable is divided by the t* corresponding to the variable being compared and its reciprocal is determined. This completes the criteria comparison matrix. The table shows the values of the normalization of the variables. Once the normalization has been performed, the eigenvector, nx1, of the criteria is determined, corresponding to each element of the row the average of the values of each row. Then the total vector is determined by multiplying the matrix of criteria nxn by the eigenvector nx1. The vector lambda is determined by dividing the values of the total vector by the values of the eigenvector of the criteria. Thus lambda max is calculated as the average of the values of the rows of the vector lambda. Once lambda max, 6.00, is obtained, the consistency index IC is calculated as the quotient of 6.00 to 6 between 5 to 1, which is equal to 0.00. We proceed to calculate the RC consistency ratio, but first we determine the random index AI, using the table of random index, RI, values for a discrete set of criteria n. For n equals 6, AI is equal to 1.24. Then, 0.00 between 1.24 is equal to 0.00, which is less than 0.10, the maximum admitted for the size of the matrix extracted from table of the maximum consistency ratio, CR. It is reiterated that when starting from a proportional mathematical relation between values, the RC will always be equal to 0. All the criteria were represented by quantitative variables, so we proceeded with the normalization method of the values of the alternatives, for the cases of contribution, plus, and non-contribution, dash, that is, depending on the nature of each variable. This table shows the eigenvector matrix of the alternatives and also the eigenvector of criteria. To obtain the general weighting vector, it is enough to multiply the nxn matrix by the nx1 vector. By ordering the results, the ranking is obtained, with the property located in PH Coral Tower occupying the first place in the selection. This table shows the comparison of results. When AHP was used with the SADI table, the general weighting vector obtained for PH Arenas Park, 0.24, for PH Vista Marina Tower, 0.16, for PH Coral Tower, 0.32 and for PH Miradors Residences, 0.28. The results of the AHP Gaussian developed by Dos Santos et al., 2021, whose authors do not use the SADI table scale or follow the traditional procedure of the method, were incorporated into this comparative analysis, the results being as follows: for PH Arenas Park, 0.23, for PH Vista Marina Tower, 0.17, for PH Coral Tower, 0.29 and for PH Miradors Residences, 0.32. The results for the proposed t* criterion are, for PH Arenas Park, 0.26, for PH Vista Marina Tower, 0.19, for PH Coral Tower, 0.28, and for PH Miradors Residences, 0.27. For the purposes of property selection, PH Coral Tower ranked 1 for AHP, SADI, and AHP, t* criterion, while for AHP Gaussian it was PH Miradors Residences. The measures of central tendency and dispersion were calculated, with AHP, t* criterion, obtaining the lowest coefficient of variation. It is observed that, for the three approaches, the difference between the ranking values, PH Arenas Park and PH Vista Marina Tower is 0.08, 0.05 and 0.07 respectively. While between PH Coral Tower and PH Miradors Residences, the difference is very similar for AHP, SADI, and AHP Gaussian, while it is minimal for AHP, t*, which evidences the robustness of the solution proposed in this research work. Discussion. When the multiple attribute decision-making, MADM, are used with an empirical fundamentation, decision-makers, DMs, are very likely to optimize the selection of the best alternative for their investment, business or venture. However, the solution provided by a multi-criteria method alone does not necessarily represent the final decision. Since the appearance of the popular multi-criteria AHP method, the fundamental scale of the SADI table has been widely investigated, with mixed opinions in the scientific community. The suggested methodology for the replacement of the pairwise comparison in the criteria and alternatives matrices by numerical matrices based on relationships between multiple linear regression model test statistics and the use of quantitative variables, requires the real estate consultant to have full knowledge of the behavior of real estate prices and the variables involved in their formation. The figure of the real estate appraiser is key to analyze the databases, and with the use of scientific methodology generate the econometric models to extract the test statistics that empirically support the solutions when the AHP is used. Currently, there are several computer programs, such super decisions, which facilitate access to mathematical calculations that allow consolidating the knowledge and development of the AHP multi-criteria method. There are also several technological tools that allow, in this era of big data and data science, the processing of data to provide solutions when it is necessary to make a decision using multiple criteria. Conclusion. The use of the matrix of the relationships between the t** statistics associated with the multiple linear regression model, MLRM, variables replaces the expert judgments in the surveys based on the SADI table, allowing decisions to be made with a sufficient degree of objectivity, thus mitigating the subjectivity in the heuristic solution provided by the AHP. For the analysis of real estate offers, the t* criterion represents a valid alternative and serves to support the work of real estate professionals, with the advice of expert appraisers, when using the AHP to optimize the marketing of real estate products and satisfy the requirements of potential buyers for the best investment decision. And finally, the happy couple was able to make the best decision for their real estate investment, which may be the only and the most important one they will make in their long life. Thank you very much for your attention.